Thanks very much, Todd. Thanks for inviting me here. I was pretty happy to come here because we think it's a pretty exciting discovery story that we've got in Côte d'Ivoire. And so happy to tell people about our discovery story. So I'll just figure out where we are. So we're Awale Resources. We've got a project in the northwest of Côte d'Ivoire. And the title is Fresh Discoveries in a New Copper Gold Iron District. And so without further ado. So I guess the idea is like, how do you get there? And we did start off as a junior company, and most junior companies will start off with a map like this that they go to people with. They'll tell people we're in a big mineral producing province. West Africa is now approaching 10 million tons of gold resources. It's a pretty exciting place to be. I've actually been working there consistently for more than 10 years now. But when I went and looked initially at the Odienne project, I didn't actually have many of those neurology sort of stories. But there was certainly, we're on a cradle margin, which is interesting to any geologist. There was evidence of gold mineralization around there from artisanal mining activity. And the traverses I walked, the rocks were altered. There was a broad alteration system. And it wasn't something that was common to what I'd seen in other classic sort of West African Birimian greenstone belts. So we didn't really know what we were going to get. And the only work that had been done is partial areas of the project had been covered by Randgold sort of broad soil sampling back in the mid-90s. And there was some pretty interesting base metal geochemistry coming out of that as well as gold. And effectively at that time, we put it on the shelf, said potentially cradle margin, crustal recycling, don't know. We just didn't know what it meant and just thought we'd go about our business. So just a quick slide on Awale, and I'll try and make the conversation a little bit light because being an exploration geologist, there's a lot of discussion and a lot of beers. And Andrew Smith, who is instrumental in putting this together, is now our VP exploration. He's also Scottish, so there's quite a few single malts involved in these discussions as well. But we sat down and like that Venn diagram, we sat down one night in front of a whiteboard and just started talking about how we go about our business. And just, being an exploration geologist, you've got to always know where you are. And that's not like geographically, it's also knowing where you are geologically. And that means being like open. And this is a mineral systems analysis sort of idea, I suppose. It's being open, stepping out and in scale. And all through this presentation, I'm going to jump in and out of scale and hopefully that's all right. But you have to be systematic about how you do things. As a geologist, you have discussions and you take leaps and you go back and look at your quantitative analysis just to see if those leaps you're taking are real, and then you might go back again and, be systematic in your exploration process. And look, I've popped the triangle over there because you've always got to be an economic geologist as well. So if you don't think it's going to work, you've got to be prepared to walk away. So at Odienne, we started with pretty much, stuck to orogenic ideas. We drilled one prospect, got multiple 100-gram-meter intercepts called Empire. It was pretty exciting for us. We moved off to drill another one called Charger, and we thought it was going to be very similar. The indicators of mapping and things were quite similar. And we drilled something completely different. And so we got some polymetallic results, some really nice gold results there. You can see we got up to 21 grams per ton in that RC hole. And it was an early stage discovery. And I guess that was a beer drinking moment too, because we were happy. But really, it was also what have we drilled? And we didn't know what we drilled. And that was a trigger for us to go off and think about other things. I've got the early stage Hitzman ideas of what an IOCG might be. We definitely had magnetite, we definitely had hematite, we had plenty of copper, we had some other interesting mineralogy coming along with it as well. And so it was, you know, interesting stuff for us. And then post that, some artisanal miners came along and dug a pit for us, which was pretty helpful. But the other thing is that, you know, we were lucky enough that Andrew and I have both got protracted histories in West Africa. And we started, and I had an opportunity to go down and look at a discovery down the road that Sentiment had made. And we started then comparing our notes and rocks and things like that. And so we started to draw the conclusion that the Western series or the coffee series right out in Western Mali were very similar to what Andrew had seen in Guinea, which is very similar to what I'd seen down at the ABC deposit. And then we also, because Andrew actually had a Randgold background, we started comparing our Odienne discovery at our charger there to Lilo Guntoko, which is one of the highest grade gold mines in West Africa. But by drawing this long bow, we started to go down a rabbit hole, IOCG rabbit hole, and various other things, but also, you know, studying the West African craton. And a chap called Granholm had actually put a paper together and talked about a deep water series which connected the Siguri Basin to KKI, and then, you know, from us it comes right down past us at Odienne. So we started to join some dots and think about some interesting ideas. And then, being an Aussie, I automatically thought about Olympic Dam and the Gawler Craton. And just for interest there, we've made them at roughly the same scale. So what we're looking at in Western Mali there is the same scale. Really, we have similarities that are probably more closer to Carias and Mount Isa Eastern Succession. But the more work that's been done, Olympic Dam is actually an outlier. But you'll see this slide come up again. But then, so again, we're going back out in scale. Where are we? We started to look at global IOCG models, where we are and how that compares. And then you're looking at a seismic velocity map there. It's pretty much showing up cratons. It's deep seismic velocity showing depleted cratonic material. But anyway, the point is that you're on the edge of craton margins, and that's where these IOCGs are. And then we thought about timing. So it's pretty compelling. Everyone knows, or any geologist knows, the South America, West Africa story, the similarities in the geology and Gondwana breakup and things like that. But when you think about when you put a temporal factor on top of things, from a timing perspective, where we are in Odienne is a very similar sort of timing perspective to Carias. So there's some, you know, big IOCG provinces, and the star there is just showing, you know, that's roughly the age of the Birimian through the Eburnean orogeny at Odienne. And so that's, you know, we are linked to that Eburnean tectonothermal event. And so just sort of coming back in again, finally you can see like back to a West Africa geology map. And I guess, and on the other side here, what we're looking at is, you know, we squeezed the life out of the regional magnetic data. So we didn't have much money. We hadn't flown our own regional mag. We squeezed the life out of it. We started to do some of our own ground mag. But, you know, we came up with a structural model that still stands up now from the further work that we've been doing and the more detailed mag that we've got. So what else? I don't know what else I was going to say there, but yeah. So look, I'll come back. Where's the pointer? Oh, there. So what we actually have here, which I didn't talk about before, is we've got a basin margin which we connect up from Western Mali all the way down past us, and along this northern margin of the craton, There has been dating done here, and this is an I-type, A-type plutonic series, quite a lot of it quite late in the sequence, and it's a big suture zone that's been stitched together with I-type, A-type plutonism, and that comes right down past our properties, and you can see there are series of plutons that come in through here, and we actually call this the Odienne wedge. And so there is this big wedge of plutonism, bimodal volcanism. There's ignimbrites, there's pyroclastics to intermediate volcanics. When you come up close to the margin, there is seafloor basalts as well. But the Archean margin is really to the south of us down here. And we have this wedge of supracrustal rocks sitting up in here. The Cassandra fault comes up and wraps around and goes off up into Guinea and eventually into the KKI. So this is just showing what I was talking about. So this is our initial interpretation. This is what we're coming on about. We're on this massive flexure in this structure where we have the Odienne wedge. The next flexure is what I call the Bankan cluster. That's developing into a pretty interesting district in Guinea. And I've actually worked as a consultant out here at some of these things. And there are late intrusions sitting underneath these things. I've seen skarns out there. And then, we draw the bow out here into the KKI inlet. There is an iron series rocks out there, the Falame iron series. There is strong iron oxide alteration at various deposits in Western Mali there as well. It's not just Lulu Bentoko. So again, just coming back to how am I going for time? I'm going all right. So just coming back, so when you start to think about these things, they're all structurally controlled, and there are a lot of similarities between what you would have as a structural model between classic Birimian geology, Southwest African craton, brittle ductile shear zones, et cetera, the IOCG model, they're big structures, brittle ductile shear zones, all that sort of thing. So, you've got exploration models in those two being quite similar, but, the Odienne district has, got a very distinct alteration style. There's a broad or a regional scale potassic alteration. In petrography, we're seeing that's overprinting an earlier sodic alteration. There are many things about what we're seeing now that are actually standing up against our initial arm waving. And so where we sit is somewhere probably at 3 there in these. Post-orogenic, syn to post-orogenic. And look, some of the signatures we see potentially sit in skarn type fields as well. A lot of the pictures you see here are from a recent paper by Roger Skiro. I'll should mention that. He's done some really nice work at trying to separate out and categorize all the many different types of iron oxide copper gold systems that exist globally. I'll skip over this pretty quickly. Look, this is just trying to compare the Odienne mineralized system to some classic ideas from IOCGs, but we've definitely got these sort of metal signatures coming in. Pretty interesting regional potassic alteration. In recent thin section work, we're now starting to find allanite, and we need to do more work on the REEs. We are exploration geologists. We're not academics. We don't have time to do a lot of the academic work, but it's something that we're thinking about now a lot, and it will start to come into play around that as well. But so there's moly. We've got tungsten in the system with a boron, cobalt, selenium, etc. And just so with that, I thought I just show you some of the rocks. So this is Charger, and so the initial, this is drill core now, but the initial sort of RC89, in the drill chips probably look quite similar to this. So we had chalcopyrite, didn't see any bornite, but there's pyrrhotite. So it's polymetallic in the shallow zones, elevated in base metals as well, and really quite interesting. We drilled a diamond hole twin where we started to really notice that iron oxide alteration. This is a later hole 83, which is a hole that shot us out of the park. I think it was 56 meters, 57 meters at 26 grams, I think it was. But it's a zone system, and it appears to be zoned so vertically and laterally. We get this sort of polymetallic sulfides higher in the system, and then we get the high grade breccias that are hematite altered, and it's hematite altered plagioclase and K feldspar. And then we get more scarny looking rocks, which are a lot more of a clinopyrexene biotite alteration, and very strongly sort of silica overprinted. And then there is also a silica breccia or quartz breccia with very strong biotite alteration in the clasts. They're really interesting rocks. I've never actually come across rocks like this before. A lot of our prospects are named after Star Wars and Dune. And so the initial ground mag that we did, we called this the Millennium Falcon. But we did recognize quite early that we had a broad magnetite alteration system. And then within that, there were DMAG zones. We've really only drilled one of those zones properly or fairly well so far. So there's certainly exploration upside in those other zones there as well. They do fall undercover, so our geochem has not worked as well there. But it's also, Charger is really cool because it's a story of tenacity. So when we drilled the initial hit, RC89, we drilled under it and around it and got nothing, effectively got absolutely nothing. But we recognized that we were in a large alteration system. We didn't walk away. We kept looking at it. And then finally, we actually came back and drilled that hole 83, where we got the 57 meters at 26 grams. And that was pretty exciting stuff and another beer drinking moment. And there was a lot of beer drunk whether we should actually be drilling underneath that again and deciding where we were. But we're confident that we're in an intrusion-related system with what we're seeing. So this is just some discrimination diagrams. These are taken from that recent Skiro paper, and we've overlain initially on this slide. It's just Charger. On the other slide, I've got four of our targets overlain on something similar, but we do get this nice clustering, and these clusters really are telling us that we're not in just an orogenic system. We are in an intrusion-related system. It is very different to other West African or the general West African examples in the Southwest African greenstone belts. So what you're actually looking at is lanthanum and cobalt on both pictures. This one over here is Cu over Au. This is the higher gold zone up here. Like so, the bigger circles are higher gold ratio, and it's also got an iron oxide sort of association. So it's more pushing up into Skiro, those IOCG, RAE sort of fields. The next slide is four of our targets that are drilled. So this is drill data only. We've got massive surface geochem data sets. Haven't included those with this. But, I guess the takeaway from this is how, all these different fields are really intrusion-related sort of fields. But at a minimum, we've got, an intrusion-related magmatic hydrothermal system. And it sort of sits in between what many of these things are, between IOCGs, skarns, oxidized intrusion-related systems. And so it's really interesting stuff, and it's something that we really want to see more work done academically in the future. Just quickly on the BBM discovery. Ooh. So BBM is really exciting for us because we integrated all these things. There was no previous data. We'd really learnt how to pull apart data. I'm just showing like metal geochemistry there, but all the way through, we've done both PXRF and ICP, done a lot of lift geochemistry and mapping our geology with LiftChem. And this was really quite cool because we actually went and drilled this based on mapping LiftChem, and we drilled 4 holes over 1 kilometre and hit the target structure in every hole. I announced the discovery and no one cared. And then we drilled some more holes. This is just for Geological Society stuff. This is a field section, the first field section off the rig. We work really hard at pen and paper when we're doing our work as well. But, I drilled another dozen holes and re-announced the discovery, and people actually started to believe me after that. Just some pretty pictures from BDM. It's a copper gold moly silver system. Strain intensity is the main sort of controller of the high grade mineralization, but we still see the same alteration. So everything that we've drilled, it's slightly different. It's got a local flavor from the local geology, but there is the same overriding alteration and mineral system that we've got. And look, that's just an example that we put together. So the guys, the people on the ground we're comparing apples to apples when we're logging drill holes. Doing it manually rather. I like the idea of box scans and things like that, but we don't have anything like that yet. Where do we go next? I mean, so we've already got Waxy in the West African Exploration Initiative. Waxy 4's been in. We'll hopefully get some dating from them soon. They've done some mineral mapping, various other things. And recently, Awale sponsored the Cardiff University Target Scheme. We should have a PhD student starting on the project next year, late this year, I think, is when they'll be starting, I think Q3 this year. And then finally, we've got our own cadetship program. So there's 3 guys there. We're paying for the rest of their geology degrees, and they're doing that part like online or part-time or however you want to put it, whilst they're learning in the field to be economic geologists and exploration geologists. So look, thanks very much. I've really got to thank Andrew Smith, who helped me put this together, and it's he has been instrumental in the journey that we've been on in the discovery of the Odienne district. The Awale technical team, they're just fantastic. They work tirelessly at collecting good data, well quality controlled. Our data sets are fantastic. Eric Roth was an excellent sounding board. He's a former director of Awale, and when he was a real sort of believer in the IOCG idea in those early days. And look, I've managed to bring one of my old economic geology lecturer back in, who now does these beautiful detailed petrographic studies, and Newmont, who have funded exploration at Odienne for the last couple of years and have been fantastic partners. Musi Jebre Mariam, there's a Newmont guy in here as well, Paul, they're on site regularly. We have really good geology discussions, and they've been good partners for us through this as well. So thanks very much, everyone. And